Okay, so I'm actually gonna record a video on the AP classroom progress checks, and particularly the FRQ questions. There's a FRQ Part A and an FRQ Part B. So Part A has this problem right here, and then this problem, and then Part B has this one problem here. So I just want to go through these and make sure that that y'all, when you get a chance to do it, that you would see, that you would be able to compare with mine and see if you're kind of on the same track. Okay. So Part A, it says that the graph of function f is shown as xy plane above. F has a discontinuity due to a vertical asymptote at x equals 6. Okay, so that vertical asymptote is right here, right? What else does it say? Let g be a function that is continuous and increasing for all x. It's continuous and increasing for all x. Values of g of x, the selected values of x are shown in the table above. So here is g, and here's f, okay? So now using the graph of f and the table for g, estimate the limit as x goes to 0 of f of x minus g of x. So this is a simple limit equation that can be separated into something that looks like this. So all we have to do is take a look at the graph of f, figure out at 0 what's my limit, and so from the left and from the right it approaches 2. And then for g of x we have to look right here, and then we want to think about, so we want to look right here at 0, and we want to think about, okay, so it's 1975, 1988, 1997, 1999, and then these two guys are so close to 2 that we could say that this guy is equal to 2, and that equals 0 for the first answer. And then part B, it says for each of the values a equals 1, a equals 2, a equals 4, and a equals 6, find the limit as x goes to a of f of x, and explain. Okay, so we just need to do all of these guys. So the limit as x goes to 1 of f of x, and then we would say that is dne, and then we have to justify, because, and then the way we would justify is just by writing out each of the one-handed limits, the one-sided limits. So limit as 1 approaches left, limit as x approaches 1 from the right, and so this is equal to 1, and this is equal to 0, and so they're not equal. Therefore, limit f of x does not exist, okay? And then, this is the amount of work that you need to show for your entire FRQ section. But I'm just going to talk through it, and I'll just write them out. But just keep in mind, to get the full amount of credit, you need to show the one-sided limits for each of these guys, okay? So the limit as x goes to 2 of f of x, in this case, would be 1. And then the limit as x goes to 4 of f of x would also be negative 1. And then the limit as x approaches 6 of f of x does not exist. Does not exist because it's because they're both going to infinity, and it doesn't exist. Okay. Part C, is f continuous at x equals negative 3? So once again, that trigger word. Okay. So using correct notation, justify your answer. So we can write it like this: f of x is continuous at x equals negative 3 if. And then the first step, f of negative 3 is defined, and then we can kind of work that out. So f of negative 3 here is f of negative 3 is 2. So we're good. So check. Number 2, the limit as x goes to negative 3 of f of x exists. So we would check the left-handed limit. We would check the right-handed limit. And so the left-handed limit is negative 1. The right-handed limit is negative 1. Therefore, it's equal to negative 1. Therefore, it works. And then part 3, f of negative 3, is it equal to the limit as x goes to negative 3 of f of x? No, it's not equal. So, therefore, f is discontinuous at x equals negative 3. Okay. Part D, write a difference quotient. Okay, so this is something that we haven't seen too much, that best approximates the instantaneous rate of change So it's the average rate of change that gets closer and closer together. That's what it's asking for when it says best approximate. So difference quotient is just another way of saying slope. So average rate of change, f of b minus a over b minus a. But we want to best approximate it at x equals 0, meaning n of g. So g would be our table. And so when we look at our table, the best approximation of 0 would be this one and this one because they're the points that are closest together. And so we use those two guys. We use negative 0.001 comma 1.999. And then we also use 0.001 comma 2.001. And then we apply that here. So 2001 minus 1999 all over 0001 minus negative 0001. And that would lead me to an answer of 0002 over 0002, which is equal to 1. Okay? All right, so that's FRQ part A, number 1. Let's go ahead and go to FRQ part A, number 2. Okay, so show all of your work, la la la. Okay, so unless otherwise specified, the domain of a function f is... Okay, so let f be... Okay, so there's the function right there, ax squared plus bx plus 2, okay? Now, here are the two things. The graph of f has a horizontal asymptote at y equals 3. So what does that tell us? That the limit as x goes to plus or minus infinity of f of x has to equal to 3. Okay? And then f has a removable discontinuity, meaning this is one of those ones that you can factor out, right? It has a removable discontinuity at x equals 2. So show that a equals 6 and b equals negative 13. Okay, so if it says show that, what I'm assuming here is that we don't actually need to solve this out, is what I'm thinking. So, for example, if I say so if we say let a equals 6, let b equals negative 13, then we can say that f of x is equal to 6x squared plus, minus 13x plus 2 all over 2x squared minus 8. And then from there, we can kind of work it out. We can say, well, first we can find the horizontal asymptote. So you can take the limit as x goes to positive negative infinity of this whole thing, which would actually be 6x squared over 2x squared. Or you know what? So just to talk it out here. So 6 minus 13 over x plus 2 over x squared all over 2 minus 8 over x squared. We plug it in, we get 0, 0, 0. And then we end up getting 6 over 2, which is equal to 3. Okay, and so from there we can say that the horizontal asymptote is y equals 3. On the other hand, what we can do after that is we can find any discontinuities. So for the discontinuities, we would go ahead and factor it out. So find discontinuities. And so this becomes 6x, x minus 2, x minus 1, 2x squared minus 4, 6x minus 1, x minus 2, 2x plus 2x minus 2. And so since these guys factor out, therefore x equals 2 is a removable discontinuity. Okay, so by letting a equal 6, by letting b equal negative 13, I'm able to work it out and eventually come to a conclusion that the horizontal asymptote is y equals 3 and that the removable discontinuity is indeed x equals 2. Okay, I hope that makes sense. Letter B. To make f continuous at x equals 2, f of 2 should be defined as what value? Justify your answer. So once again, to make it continuous, it's those 3 steps like we always say. F of a is defined, the limit exists, and then the f of a is equal to the limit, okay, as x goes to a of f of x, right? So f of 2 should be defined as what value? So justify your answer. So right now, when we put 2 in there, because of this removable discontinuity, right now f of 2 is undefined. Right, but we want to make it continuous. So what we need to figure out is what is going to be the limit of this guy as x approaches 2. And so if we so you would need to show more work than this, but if we glance ahead, you can kind of see that it's an indeterminate form. So we factor and we reduce, and then we can plug it into that. So 12 minus 1 is 11, and then 2 times 2 plus 2 is 4. So that's 11 over 8. So that's the value that we need it to be, because we need the limit and the value to be equal to each other in order for it to be continuous at x equals 2. Okay? Now, what I wrote here is probably not sufficient, but hopefully as you're following with the words that I'm saying, it makes sense to you. Okay? Thirdly, at what value of f x does f have a discontinuity due to a vertical asymptote? Give a reason for your answer. So just taking it back to our function here, we know that our vertical asymptote is equal to is x equals -2, and we know that that's the case because it's a non-removable discontinuity. However, to show that it's a vertical asymptote, we need to find the limit as x goes to -2 from the right. And then we need to find the limit as x goes to -2 from the left of this guy. Okay. And then what we'll notice with this function here, 6x minus 1 over 2 times x minus x plus 2, is that this becomes like 2 times, and then if you can imagine -2 from the right to be like -1.999, then this value here becomes 0.001, and then this becomes like -12, so this is like -13, and so 2 times 0.001 is like 0.002, and if you divide by, do you see how big that is? So this might as well be approaching -infinity, whereas this one would do something very similar, so -2.001, but instead it would be -13 over 2 times -0.001, which would be -13 over -0.002. So do you see what happens to that? It might as well be infinity. And so from the right, it approaches -infinity. From the left, so from the right, it approaches -infinity. From the left, it approaches +infinity. So that tells you that it's going to be a vertical asymptote. Okay, that's the kind of work that you need to do to justify it. Justify yourself getting full credit on that, okay? And just quickly in the next, because I have class in 4 minutes, but let me just race through this here. So this is just a classic IVT problem. So t goes to infinity of n of t. So we're going to plug it into this one right here, 200 plus 80t over 2 plus 0.05t. Why? Because of that right there. Going to infinity would only be the ones that are values that are greater than 8. And this comes out to 80 over 0.05, so that's 8,000 divided by 5, which is equal to 100 and, let's see, is that right? 81, 30, 160, okay. So 1600, okay, so that would be that. And then explain the meaning of it, so that's what it approaches, right? Whatever this problem is about, the number of fish. Okay, approach is 1600. That's the capacity. Okay, letter B is it continuous at t equals 8? Same thing. So first find f of 8, find the limit as x goes to 8. Sorry, let's just match it with the letters that they give to us. And then lastly, does n of 8 equal the limit as t goes to 8 of n of t? So for 8, we need to check the left-handed and the right-handed. So limit as t goes to 8 from the left, and that would be the 25t minus plus 150. And then from the right, that would be the 200 plus 80t over 2 plus 0.05t. Okay, that's the idea. And then this one is the continuity thing. So the function n is continuous, so that's condition number 1. Then condition number 2 is to find n of 6 and n of 0, and to show that they are not the same. Okay, and then to show by IVT, there exists there exists a t in the range from 0 to t to 6, such that n of t is equal to 250, because 250 is between whatever these two numbers end up becoming. Okay, so hopefully that's helpful.